Okay, so the question says, upon analysis, a compound was found to contain 66% of potassium, 6.1% of boron, and 27.3% of oxygen. The empirical formula is, so here's a tip. Notice that the percentages all added up to 100%. So we're going to treat this like we have 100 grams of the compound, and you'll see how that'll help us out. So we would have 66.6 grams of potassium, 6.1 grams of boron, and 27.3 grams of oxygen. So let's determine how many moles we have of each of these atoms. Well, we need to look at our periodic table and see that potassium has an atomic mass of 39.1, and that's how much 1 mole of potassium would be. So using this conversion factor here and knowing that we have 66.6 grams, we will basically divide this by 39.1 to see how many moles we get of potassium, and it would work out to 1.7 moles. We'll do the same thing with boron, which has an atomic mass of 10.8. So we would divide our 6.1 grams by 10.8, which of course would be just a little less or almost half of a mole. For oxygen, with an atomic mass of 16, we would divide our 27.3 grams by 16 to find out how many moles of oxygen we have, and that would give us 1.7 moles. So in step 2, we want to determine the mole ratio of each of these elements by dividing them, each one, by the smallest amount that we came up with here. So for potassium, we found 1.7 moles, and the smallest amount we found over here was 0.56. So we want to know how many times 0.56 can go into 1.7, and it is about 3 times. For our boron, where we had 0.56 moles, of course, dividing that by 0.56 would give us 1. And for our oxygen, where we had 1.7 moles, we divide that by 0.56, it goes in 3 times. So this lets us know how these elements relate to each other in this compound. So we would use these ratios to figure out our empirical formula. And in this case, we would have 3 potassium, 1 boron, and 3 oxygen, giving us potassium borate, which is sometimes used in cosmetics.